Okay, so in this section we are going to study about the motor, starter and control panel. So first focus will be on the motor. So the motor used in the purifier is class F, is a special kind of insulation. Okay, class F insulated 3-phase squirrel cage type induction motor. So basically we have class F insulation induction motor. Okay, now the important point here is the purifier motor has got a certain starting characteristics that we need to study in this section.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respectonship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respectonship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Okay, as we are aware that power transmission is taking place from the purifier motor to the friction boss, from the friction boss the friction pads or the friction clutches move and slide over the friction pulley due to the centrifugal action, and due to this sliding action the starting current or the starting load is mitigated. Okay, because as soon as the motor is started it immediately reaches at its rated speed. Say 1400 is the rated RPM of the motor. As soon as the motor started it reaches its rated RPM. So to avoid starting load, it is slowly started, and it is power transmission takes place through the friction clutch mechanism that we have seen. Okay, so gradually it accelerates to the higher RPM. The bowl increases the RPM. Okay, now one important table here is that the motor which is used for the purifier should have this overload capacity. Say for the duration of 1 minute it can be able to sustain 100% overload. That is called 200% overload protection for 1 minute. So 100% overload. If it is a 7.5 kilowatt motor, for 1 minute it should be able to take 15 kilowatt and do not trip. So for 1 minute 100% overload protection, for 5 minutes it should have 75% overload protection, for 15 minutes it should have 50% overload protection, and for 30-minute period it should be able to run on 25% overload. Okay, so that is one important aspect of the type of motor. That is why it is called 200% overload protection for 1 minute, the purifier motor. And subsequently it reduces 75% में 5 minutes तक it can run, 50% overload में 15 minutes it can run, and 25% overload में it can run for next 30 minutes. Okay, now come to the starting characteristic curve. Okay, so if we need to explain this one, we can see on the x-axis, we have the time here in minutes, and on the y-axis one parameter is the RPM, which is per minute revolution speed RPM, and the electric current. Okay, so RPM is of the bowl RPM here. So not just the bowl RPM, so RPM in general about the motor and the bowl which is in the assembly. So RPM is in this part, and we have current. So at 8000 rpm we see it's a 40 ampere current. So we have taken here SJ50G model, 7.5 kilowatt motor, 4 poles, 440 volt and 60 hertz. This is the motor rated capacity. Now let us see this diagram. So on the top here is the revolution of the ball, revolution speed of the ball, RPM, how it varies with respect to the motor characteristics. Then we have the rated electric current. Okay, so rated current for the motor is fixed 12.7 amperes. Okay, so we have a dashed line here, 12.7 ampere per. Okay, so this line, dotted line, is the rated current. Okay, then we have the graph for the electric current drawn by the motor. So this is the actual curve for the motor current drawn by the motor. Okay, so here we are trying to draw a relationship between the RPM of the bowl, electric current drawn by the motor, and the RPM of the motor, revolution of the motor, revolution speed of the motor. Okay, so this curve at the down one, let's check a different color for this. Okay, so this curve here is the RPM of the motor. Let us see one by one what happens, how we during the starting period. So at 0 time, as soon as we have pressed the start button, start push button, we can see the electric current that the motor has started drawing. So the motor is set to draw the maximum current during starting, and the RPM within few seconds, you can see that the RPM has reached to the fixed RPM of the motor, revolution speed of the motor. So revolution speed of the motor is, we can see, is constant throughout. In case of any operation, it is constant. Only once it is dropping here and again rising. Okay, let me show here. So only once it is dropping here and then again rising to the same value of RPM, around say this 1400 1600 RPM. So during, after the desludge, just after the desludge, when the bowl has opened, then the RPM drops, the motor RPM drops by a few RPM. Why? Because there is a sudden change in load. The bowl has opened and the load has suddenly changed, due to which there is heavy electric current being drawn at that time, due to which there is a drop in RPM. Okay, we will relate the both of the RPM of the motor and the electric current subsequently. Let me just see this one. Okay, now what happens? See, as we have started the motor, in a few seconds the motor RPM has come, motor has continuously started running at the rated RPM. चलो ठीक है, अब क्या हो रहा है, इधर मोटर ने करंट, मोटर स्टार्टेड ड्रॉइंग करंट. सो इनिशियली starting current will be very high. As we see, during the starting period, the motor starting current is very high. Then what happens? The current starts dropping as the friction clutch starts sliding over the bowl. Friction clutch starts sliding over the pulley. So as the pulley is starting to gain RPM, the current drawn slowly comes down, as we can see here. So generally, as we have seen that bigger motors takes 5 to 10 minutes for initial startup operation. So minimum is 5 minutes for startup operation, and then for the big ones above SJ 50 60, above 50 60, it is 10 minutes. Below the SJ50 model you have 5 minutes. So in this one we have 5 minutes of startup time. You see, this is the 5 minutes time, and the motor has taken up excessive current and then again settle down, and slowly it starts dropping as soon as the friction clutch starts sliding and the RPM of the bowl starts to pick up. RPM of the bowl start to pick up. We can see the bowl RPM. So bowl RPM, see, initially the bowl was at standstill. As soon as we have started the motor, slowly the RPM has started rising. So during this period, during the bowl RPM was very low, below 3000 4000 RPM, the motor was drawing very heavy current. As the RPM has increased to 7000 RPM, around 7500 RPM, we can see that the current has also reduced. Okay, we will in this diagram we can see it more clearly. So as we can see here, this is the completion of startup time. So in this point the motor has picked up the RPM and slowly it has settled. The bowl has picked up the maximum RPM and it has settled here. So when it has settled, the motor has also started drawing minimum current. Okay, even the current below the rated electric current. So electric current is 12.7 amperes. Below the rated current, the motor has started drawing current at that time. So completion of startup period is 5 minutes. After this period, the sealing water goes. And during that time there is no change in current, because the bowl is not facing any causes of interruption or vibration or something like that. Then we start feed. As we start feed, that time the bowl is filled with oil. So as the bowl is filled with oil, the load becomes more and the motor starts drawing a little bit more current. Here we can see the current value has increased. Okay, current value has increased, and as the purification starts, and we have oil in the outlet also. Okay, so during this period the purification is going on. The bowl is now running, say, period from 5 to 6 minutes to around 8 minutes. This period we have no outlet. So outlet is not there, only oil is going inside, due to which the load has increased on the bowl, and since the bowl load has increased, the motor started drawing more current. Whereas you can see there is no sudden change in the bowl RPM. Bowl RPM is constant around this period. Okay, as the current drops and the oil, we have the oil outlet and heavy liquid outlet, the current has almost become steady. Now when the current will change, next time when we stop the feed. So when we are stopping the feed, we can relate to this point. When we are stopping the feed, at that time, due to sudden load change, so motor was running the bowl at certain RPM and the bowl was settled with the amount of feed we are giving it, and it was purifying the oil. Oil was coming from the oil outlet, clean oil outlet side, and heavy liquid outlet side, water was coming. So it was set to operate at that system, and as soon as the hydraulic system has a change in momentum, so as we stop the feed, there is a change in momentum. So that sudden change in momentum causes increase in causes little bit increase. We can see here the curve is showing a increase in current value. That is, as we press dislodge, the first thing is the feed stops. Okay, feed stops and the replacement water goes. So as soon as the feed stops, there is a increase in the electric current. We can see this in our ammeter. So that is what we note, that now dislodge has started. So as there is increase in current, and during this time the motor, as the bowl opens up during this phase. So you can see as bowl opens, the bowl RPM has dropped. Why? Because the bowl opens, the main cylinder is sitting down. Now the main cylinder or the sliding bowl is detached from the top part, which was making it a sealed bowl, due to which the load was more. So as the bowl opens, the lower part is sitting. So when the lower part sits, there is a sudden jerk that is noticed here, with increase in current. Here, increase in current during the discharge as the bowl opens, and the RPM drops in this period. And as soon as the bowl closes, the RPM of the bowl drops. As soon as the bowl closes, we see a drop in the electric current again. So the bowl opens, with sudden jerk, the cylinder goes and sits down, due to which the load on motor increases. Load on motor increases, so electrical load increases. Your motor draws more current, whereas the load on the bowl reduces. So RPM of the bowl reduces, but motor load increases. So that is why we see here there is a drop in the bowl RPM, but increase in the motor current. So when we are dislodging, we see there, what we see is the RPM, the ammeter, we see the full deflection of the ammeter. That is what it is showing, that the dislodge is taking place. So that means the bowl has, when we hear the sound tuck and the bowl sits down, so the motor gets loaded, motor gets loaded, due to which the current increases, but the bowl RPM drops at that moment. And with this sudden dropping of the main cylinder, okay, or opening of the main cylinder, or sitting down on the main cylinder, at that time the motor RPM is also suddenly dropping for a small amount of RPM and small amount of time, say this one, for the next 1 minute or something like this, until the dislodge operation is taking place. So motor RPM is also dropping, and then the motor RPM picks up to be steady. Also the current becomes steady when the bowl closes and there is a continuous feed into the system. So this is the starting characteristic curve of the electric motor and the bowl, and the relation between the RPM of the bowl and the motor. Okay, so that is all in this section. In the next section we will study the characteristics of the starter.